Hello world, welcome to New Jack Education. Today I'm going to take you through a quick lesson about power use, energy consumption. And we're going to relate energy consumption to the cost as well as emissions. So let's ask a quick question. How is power produced? And what are the costs of producing power, or the byproducts of producing power? So to turn this light bulb on, bing, to create light, so when it's dark out, I need to turn on this light, so I connect it somewhere into the outlet, I turn on the switch, and energy goes into this bulb, it illuminates what's inside, and it creates light so I can see in my room and not run into things, and I can do my homework and I can do whatever I need with light. So alright, so how does light get to this bulb? Well, first it has to be generated at a power plant. So for us in Detroit, in the Detroit area, it's generated by DTE. So we have coal plants, we have nuclear plants, we have renewable energy like solar panels and wind turbines, and power is produced by each of these different means. And then we have all the wires that run from the power plants, and they go to transformers in different communities, but ultimately the power from the power plants is put through these lines and they come into our house. So I'm at my house in my backyard. I'm just going to show you real quick where these lines, so they're kind of hiding up in the trees, but it's going to come down, and this is where all the power coming into my house is coming from, right here. So what is this thing on the house here? Okay, so we have this box or electric meter, and all buildings will have one of these, and this shows how much electricity is moving in to my house from DTE. And right here, this is where it measures how much energy my family and I use in our house. So you'll see, let's see the number that pops up, 32946, and that's kilowatt hours. So that's how many kilowatt hours we've used. I don't know how much time total, but anyways, traditionally a meter reader would have to come and write this number down and then bring it back to DTE, and that allows DTE to charge us. So we pay DTE per kilowatt hour of energy. So let's see here, it's going to come up one more time. Let's wait for it. Alright, so 329.46. Let's wait for it. It's going to be the next one. No. So it's going to tell me in a second our monthly energy use. Maybe not. But anyways, this goes into my house, into our house, and all of our electricity that we turn on lights with, that we charge our computers, play our game systems, run our dishwashers, so on, and it's all going to come in through there. So anyways, let's try to put this all into perspective. So at the power plants, energy is produced, and we could talk about how that happens, but that's a whole nother lesson. But anyways, that energy is distributed through lines into our meter on our house, and that's how the utility companies measure how much electricity we use. So let's ask questions here. So let's do a home energy use analysis where we can take different objects from our house, different electrical objects, and today I have a light bulb, I have this cool record player, this kind of mini record player, as well as this space heater, which I use in the winter to keep me warm. So what we're going to try to figure out is how much power do these items consume? What is the cost associated with consuming that power? And what are the CO2 emissions associated or related to using that power? So we're going to connect these three ideas here, and I've created this little chart to help us kind of keep track of some numbers. So the first thing we're going to do is we're going to select an item, and just to keep it simple, I'm going to use this light right here. So now every electronic item that we have, by law, it must include different power information. And right here you see this light, the power rating is 8.8 watts. So that's something I could write down. But you know, so we have our light bulb. So I'm going to use a light bulb. You could choose whatever you want, but I'm going to grab this bulb here. And the power rating is 8.8 watts. But just for the sake of simplicity, I'm going to pretend that it's a 10 watt light. And that's just going to make our calculations later on a little simpler. So we have this 10 watt light that's going to produce light for us. And I just want to show you with these other items that we also have power ratings. So this one particularly, this is a 1500 watt compared to a 10 watt. So this takes 150 more times power to run than that light bulb. And then here with our record player, which this thing is going to spin when it's turned on. It has speakers on the side, so it's going to play some music. And this right here has, let's see, 19 watts of power. But anyways, let's go back to the bulb. This is what I'm going to study for now. And first, let's just write down that power rating. So I have a 10 watt bulb. I wrote down that power rating. And now let's estimate how much time are we going to run that every day. And I'm going to just say that I'm going to run this for 10 hours every day. So I need this light to be turned on for 10 hours through the night so that I can stay up and do all of my graduate studies, so I can be a teacher. So anyways, we have our power and we have our runtime, and we can use this information to calculate our daily power usage. So a quick thing, what is power? Well, at least in an electrical sense. So power is energy that's used over a period of time. So when we take, and of course, let me say, so power, we use a unit called watts, and that's how we measure power, is with watts, which again is how much energy we use in time. So let's take this right here, and we are going to use 10 watts. So we have 10 watts of we have a 10 watt bulb, and we use it for 10 hours per day. All right, so 10 hours per day. So that is going to give us a total of 100 watt hours. So we multiply those together. Now we have 100 watt hours each day. So if you remember when I looked on the box over in the corner, the meter, the energy meter, we saw that it was displayed in kilowatt hours. So now I'm going to take my 100 watt hours and convert that to kilowatt hours. So for every 100 watt, or for every 1,000 watts, that's going to be equal to 1 kilowatt. So we can take this here, so our 100 watts, and apply this little conversion factor. So if we take 100 watts, and let's see here. So there are 1,000 watts in 1 kilowatt. So now our watts will cancel. We're still left with hours, which is cool. And now we take 100 and we divide it by 1,000 here, and that's going to leave us with 0.1 kilowatts. So if we take our 10-watt light bulb, run it for 10 hours a day, and we do our little conversion, this bulb, if we run it 10 hours a day, is going to use 0.1 kilowatt. Oh, I forgot my hours. Kilowatt hours. You can see that's still there, right? And my kilowatts is still here. We multiply those units together. So our daily power use for our light bulb is going to be 0.1 kilowatt hours. All right. So far, we have considered that we need to put energy into this bulb to light it up. And it needs at least 10 watts to power it. And we're gonna run it for 10 hours in a day, which it will use 0.1 kilowatt hours per day. So now that we know how much power this bulb will use in a day, let's calculate the cost it's going to take us to run this bulb for 10 hours. So again, the energy company, they are charging us, so for every 1 kilowatt hour we use from the company to run all the electronics in our home, they are going to charge us, my bill's about 10 cents or 12 cents per kilowatt hour, but let's just make it easy. Let's make it 10 cents, and that's a good enough estimation. So this means that every kilowatt hour of energy we use at our homes, it's going to cost us 10 cents. So we can convert this right here to the amount of money it's going to cost us to run that. So we can apply another conversion factor here. So I'm going to take my 0.1 kilowatt hours, and each kilowatt hour costs 10 cents. So when we run this quick calculation here, our kilowatt hours, that's going to cancel out. And we're going to be left with dollars here. And when we multiply 0.1 by 0.1, that gives us 0.01. So this is our cost per day, which is 1 cent every day. So to run this light bulb, so we got this light bulb here. It needs 10 watts of power to run. We're going to run it for 10 hours a day, which uses 0.1 kilowatts of energy, and that is going to cost us 1 cent. So we got our dollar sign, we got the dollar place, 10 cents, so 1 cent it costs us to use this every day. So far, we've thought about power consumption in that we need power to run our electronics, and power is energy, but it's also how much energy is used in a period of time. So we are considering hours, and we're going to run that light for 10 hours, which total in a day is 0.1 kilowatt hours, which costs us 1 cent. And now let's convert that energy use to CO2 emissions. So there is a website called EIA.gov that I believe is the Energy Institute of America, and they say, according to them, they say that every kilowatt hour of energy that we use, it creates about 0.99 pounds of CO2. And let's just take this 0.99 and let's just call it a solid 1. So we're rounding up a little bit, but that's okay. So we're going to say that every kilowatt hour of energy creates about 1 pound of CO2 that goes up into the atmosphere, and then the sun puts radiation into that CO2, that pound of CO2, and it holds on to the heat. And that's what we say is the cause of global warming, or one of the issues, is that we're producing so much energy, right? We have this power consumption because we consume so much energy. And of course we have to pay for that, but also implicit cost is that there's cost to the environments, be it that we're putting CO2 up into the atmosphere, and when the sun pushes radiation through our atmosphere, the CO2 acts as a conductor, and it conducts that heat and it holds onto it. And that's what's heating up our atmosphere, and we could connect that to global warming. So this is how our power consumption, sure, it costs us money, but it's also impacting our environment. So this is a simple conversion factor. So for every kilowatt hour, we have 1 pound of CO2 that goes out into the atmosphere. So let's see, how many pounds of CO2 does our light bulb create in a day? So we go back to, of course, we used 0.1 kilowatt hours. So really simple conversion here. So 0.1 kilowatt hours, that's how much energy we use in a day through the light bulb. And we're going to do a quick conversion factor. So every kilowatt hour produces about 1 pound of CO2. So the kilowatt hours cancels out. And this is a pretty much 1-to-1. So that 0.1 kilowatt hours becomes 0.1 pounds of CO2. All right, so again, how much does our bulb produce per day? And that is going to be about 0.1 pounds of CO2 that we put out into the atmosphere. All right, so we have this bulb, and it takes about 10 watts to make it light up and produce the light we need to see at nighttime. And if we run it 10 hours through the night, it's going to generate or use 0.1 kilowatt hours of energy. And it's going to cost us 1 cent every single day. And then it's going to put 1/10 of a pound of CO2 into the atmosphere. So something we could do real quick, let's take this and multiply it by, let's see. So this is all the power we use and what it costs us and how much CO2 is created by running this bulb each day. So let's say we wanted to see in 10 days, how much would this cost us? And in 10 days, how much energy would we use? And in 10 days, how much CO2 would we emit? So if we simply multiply each of these values by 10, we could scale. So if we use it for 10 days, this is going to become 1 kilowatt hour. This is going to become 10 cents. And this is going to become 1 pound. So if we run this light for 10 days, it's going to create a kilowatt of power, which is going to cost us about 10 cents. And it's going to create about 1 pound of CO2 in the atmosphere. All right, so you could do this analysis for your other objects, be it your record player, be it your space heater. Hey, you could even go to bigger objects and bigger items like your air conditioner, which uses way more energy, way more electricity, costs you way more to run, produces way more CO2 into the atmosphere. You could do the same thing checking with your TV, your game systems, your cable router, your modem, your box. Look, everything you have plugged in, everything you run is going to be using energy. So next time you turn on that light, think of What is this costing me? How much do I have to take out of my piggy bank to pay DTE to produce the energy to light up this bulb? And also, what is the impact I'm having on the environment and in the atmosphere by running this bulb? So that's a quick rundown on how you can perform your home energy analysis activity. I'm Jack with New Jack Education, and I will see you next time. Cheers.